All right, moving on to example number 4. Again, we're going to do the exact same thing that we've done in the last 3 examples. But again, we have to look at this specific context to see and understand this situation so that we can find our equilibrium concentrations for both of these gases. So our reaction is N2O4 producing NO2, right? So writing our equation, N2O4, double arrow, 2 NO2. Both of these are gases. So I'm going to start off as usual by making my ice table. So initial, change, and at equilibrium. And initially my concentration of dinitrogen tetroxide gas, so is 0.500 moles in 1 liter. So the concentration of that is going to be 0.500 moles per liter. We start off with no nitrogen dioxide, but looking at our coefficients, we can figure out our change. So I know that this does have a value, a concentration initially, so that is going to decrease over time. So it's going to be negative x. And because the coefficient is 1, we're just going to leave that as negative x. Because we didn't have any nitrogen dioxide to begin with, we know that as it approaches equilibrium, it's going to gain concentration. It's going to gain, so that's going to be a positive. The coefficient is 2, so that's going to be 2, and it's going to be x, so plus 2x. So our expression for the concentration of N2O4 at equilibrium is going to be 0.500 minus x. And our expression for the concentration of NO2 at equilibrium is going to be 2x. Again, because we have these expressions, we can use our k value to solve for x. And our k value given in this question is 4.50. So let's take a look here. So let's write our formula, our general formula down. So our concentration of the products, NO2 to the power of 2, divided by the concentration of our reactants, N2O4. And then we just plug in our expressions to see where that gets us. So I know my k value, so I'm going to write that in as well. So 4.50. NO2 squared, so 2x squared. And that's going to be 4x squared, right? Because 2 is going to be squared to make 4. X is going to be squared to make x squared. And in the denominator, I have 0.500 minus x. Now I could, and here's where, based off of the last 2 examples, we should check to see and do the test, right? Take our initial concentration of 0.5 and divide it by our k value, which is 4.50. You'll notice that in this case, it is not greater than 500, which means that we cannot make that assumption that we did before, which means that this x value has to stay. We have to use this and solve for the value of x with this there. Okay, so what we're going to do is we are going to expand this. So what I want to do is take this over to the other side. So I'm going to get 4.50 times 0.500 minus x is equal to 4x squared. And expanding on this, so I'm just going to make myself a bit more room here. To expand on this, I am going to do 4.50 times 0.5, which is going to give me 2.25 minus 4.50x, right? So I've just multiplied this by this and this by this is equal to 4x squared. Now moving this all onto one side, I'm going to get 2.25 minus 4.50x minus 4x squared is equal to 0. Now setting it up this way, this reminds us that this is going to be solved using our quadratic equation, which is negative b plus or minus square root of b squared minus 4ac over 2a. When I plug in both of these numbers, there's only one number that I'm going to get. Sorry, when I plug in these numbers into my formula, there's only going to be one possible answer. One is going to be negative, one's going to be positive. We can only take our positive value. And so we're going to find that X is equal to 0.375. The negative number of X, we cannot use it because that doesn't make any sense in our context. So if we take a look here, we're going to start with our start by finding the concentration of NO2. We know that the expression at equilibrium is that it's 2 times the value of X. So 2 times X, 2 times 0.375, which gives us a concentration of 0.750 moles per liter. Now taking a look at our concentration of N2O4, we know that the expression is 0.500 minus X. And when I solve for that, my answer is going to be 0.500 minus 0.375. I'm going to get 0.125 moles per liter. So that is example number 4.